There we go. Okay, welcome all. We have a busy schedule today, so we're going to get started right away. If you're not sure, we're at the W3C OGC workshop on maps for the web. This is day 3. If you missed day 1 or day 2, I think they are both now up on YouTube, and we will get the links integrated into the agenda soon. There is also the ongoing live chat on Gitter, and there are multiple links to it now from the Zoom chat, and more long-form discussion on Discourse, and somebody can throw a link to that into the chat as well. I would like to remind you that we are operating under the W3C's Code of Conduct, and respectful behavior is expected from everyone. Beyond that, I think we're going to get started. Our theme for the first hour is a native map viewer for the web platform. Can we add something to the web that tells browsers how to display maps? On that theme, we have 4 different talks. To start it off, we have Bryan Kardell. Bryan Kardell works at Igalia as a advocate and networker extraordinaire. But even before that, he's been involved in web standards in various capacities. He's going to be talking to us about extending the web with new features and something about pi. So I hope you brought enough for everyone, Bryan.
Okay, I'm going to share my screen. Let me know if you can see that.
It's working.
Okay, and I'm going to also drop in a link, and if you open that link in your Chromium or your browser tab, it should advance as we go, and you get a smoother experience probably if you prefer that. Okay, so yeah, I'm Bryan Kardell. This is my website. You recognize it as a website because you see it in a web browser with a URL. But in that same browser, you can do pretty much anything that you would want to do on a computer, which is amazing. But also many of the desktop apps and mobile apps that you download and use as first-class things on your devices are also under the covers using web engines. And so are lots of embedded devices now, your smart refrigerators, your TVs, car and airplane infotainment systems, digital signage, point-of-sale systems. Basically, as long as there's a UI, you can bet that there's somebody working on trying to do that with web technology. In fact, even if there isn't a UI, we're using aspects of the web platform. Even if you just went out into the forest or on a remote beach somewhere and read a paper book, there's a pretty good chance that web technology and web standards were involved in the printing and creation of that book. So what I'm trying to say here is that the web platform is infrastructure. It's a huge commons on which we've built basically all of society at this point. But if you're on the edges of that and you're trying to improve the platform and you don't work for a vendor, you're just a developer, you want to make things better, it can feel a little bit frustrating sometimes. It can feel like you've been put on hold, and even though they might say, your call is important to us, it sure doesn't feel that way sometimes. So part of my talk, I want to give a pep talk here. Yes, I think we could do this, but I would also like to explain the reasons why it can feel this way and the practical challenges and kind of keep us grounded in reality. So the reason is pi. That needs some explaining. So as an illustration, we're all here giving some amount of our finite time and energy pi to think about and discuss this topic. Now, we all have different amounts of pi. Some of us are here because it's a labor of love. We just really believe in it. We think it's the right thing to do. And lots of others of us work for companies, and our companies have obviously different amounts of pi. We have very, very different budgets of pi as we're coming into this discussion. And some of us bring the most pi. We bring the most critical pi. And the ones who make the rendering engines are the most critical. But it's important to recognize that their pi is still finite. And also, it's voluntary. It's not cheap. I want to point out that there are thousands of person years investment into each one of these rendering engines. And that is just the code part. That isn't the standards part, which is really, really big. The wants from folks like us as the commons grows are only accelerating. And every want represents an ask for some slice of pie. And the slice, how much we're asking for, differs from engine to engine because these are different companies with different budgets, and they have different constraints and priorities limited to staffing and talent. And they also have different architectures, so things cost different amounts. So realistically, they have to prioritize. There is absolutely no choice. But lots follows from this. It has a big domino effect. The first one is, in order to be involved in any discussions, they, just like we do, have to make some value judgment. We're not doing other things that we could be doing right now. We're doing this, and we're doing that based on some judgment. But how do you estimate what it takes to be involved is very difficult if you're a vendor because you know what it really takes. And so lots and lots of stuff takes a really long time to get past go, or some things never do, or maybe some things just haven't yet, like maybe maps. So the result of this is that in 30 years that the web's been around, we have created about 130 elements for HTML. And over half of those are just spicy divs, is how a friend of mine, Dave Rupert, calls them. These are things like paragraphs, strong, emphasis. They have very low implementation costs, but very, very high standardization costs while we discuss them. But even if you make it past those steps, now you get to where we have to actually get it done. And we have to get it done everywhere. We have to get it done interoperably, which we frequently learn along the way. We have to get it accessible and stylable, which are things that we frequently still get wrong, especially in early implementations. And costs go up very quickly with complexity, like even a little bit of complexity. So to illustrate this, in 30 years, we have created one non-form-based interactive standard UI control element, like the sort of thing that you would find in a standard UI toolkit that isn't about collecting information. And that is summary details, which looks like this. It is probably the simplest UI widget in existence. It has been around as long as there have been GUIs. And this has been a work in progress for a long time. The last major browser added support in January of this year. And that was accomplished, actually, the full parity was accomplished by one of the rendering engines disappearing. When Chrome switched their internal rendering engine from theirs to Chromium, they just got it by default. And then finally, if you make it past all of those hurdles, it's finally real. Like, it is actually literally, everybody can use it. It works everywhere. It is by all definitions a standard. But that doesn't mean that everybody knows that we've reached that point yet. So it takes some time for people to learn about it. And then it takes even more time for them to find a use case where they need to try it. And then finally, at that point, we get developers involved way, way at the end. And we ask them, hey, how is that super expensive pie taste that took a decade and millions of dollars? And the response is frequently, it could be better, to be honest. So that sounds very, very depressing, but that is sort of like the historical challenge. And that is why several years ago, a group of us got together and discussed these problems and created this document called the Extensible Web Manifesto. And what it says basically is we can do better than this. One way we can do better than this is that the cow paths currently aren't very clear. We say that we pay the cow paths, but really, it's a little bit like reading the runes. We're looking at many other cow paths and trying to build a new road that meets all of the same criteria in a completely different way. So a better way to do this is to give developers mostly the same abilities that browsers have to create new elements. And let developers bring the early pie. They're the ones with all the ideas, and they're the ones that are actually capable of testing things. They're the ones that are ultimately have to accept the solution as adequate. And we can find out, do developers actually like and use it or not? Because very frequently we are wrong. Because failure in this model is a feature, right? Like we can float lots of ideas, and people can say, what about this? This seems great. And people can say, no, but we can do better than that and very quickly adjust. This also, I think, plays into the ability for us to explore adjacent possibles. When we give people new tools, they dream new dreams that we hadn't even thought of yet. I think this is important because so many things wind up being fantastically successful at something they weren't even designed for, including the web itself, actually. So this document suggests that we should get out of the way. We should enable developers to explore these spaces. We should give them the tools, and we should not spend those precious resources debating how developers might use things or what they might like, and give them the tools to show us, and focus on science to know when they've discovered something so that we can write it down, and that can work more like dictionaries. There aren't committees for dictionaries that create words. They write down the words. So this is all high-level stuff, but I think there are some important details, at least they're important to me, that I would like to discuss, which is that one of the goals here, in my mind, is for this to lay a nice, bright, unambiguous path that we can then pave, that has proof that is accessible, that is acceptable to developers, that it ticks all of the boxes, and it is estimable. And it explains how does this map very well to the web platform. So I think that what the Extensible Web Manifesto is saying, a lot of it is to break it down, to reduce the magic required in anything, expose the parts, and aim for the middle. So an example of this is dialogue. Dialogue is this element that is in almost every UI toolkit. And it creates this layer on top that you interact with. But it also does all of these other subtle things. And inside it is magic, lots of magic. It does things like prevent you from selecting the text behind it, prevent your tab focus from moving out of it, give you controls for styling that, and so on. Change how things are exposed to accessibility. So the original proposal for dialogue is a big ask for budget. And if we succeed in delivering it, we'll deliver that thing I showed on a few panels ago. And will it be adequate? We don't know. But it will be helpful in solving only that problem. But if you crack open the magic, there is this concept of inertness that is used to define dialogue, which is all that other stuff that I said it does about managing text selection and ARIA and everything. And it's fundamentally necessary for dialogue, but it's also useful for lots of other UI patterns and components that we haven't even started talking about standardizing yet. Maybe some that we never will, like drawers. So we split that out and made inert exposed to developers, and we focused on doing that first. So that delivers a lot of value for a lot of things that can explore the space, and it reduces the overall amount of pie that is required for dialogue. That changes the calculus of whether it's worth the investment. It's much more estimable, and it is very much follows basic software development ideas. Then it allows developers to use inert to explore the space with other controls. And the way to pave those controls then is very clear because we know that is inert. We don't have to reinvent that. So exposing these middle layers actually helps build resilience and adaptability. It helps make sure we're not biting too much off. And as the web changes, like we have the ability to adapt. So what's all this got to do with maps? I know it feels like I'm a little bit off topic, But should the web have maps is the question we're asking. And yes, it seems clear, sure. But we need so much. There's so many things that the web should have that the web doesn't have, and there's just not enough pie. So another thing you can do is you can bring more pie. My company, Igalia, that's what we do. The reason that the current model, the historic model exists is simply because that's what we let happen. But Igalia and other companies like Bocoup, who's presenting also today, can help you when you have prioritization problems where you can't get the attention that you need from somebody who has the expertise and the knowledge to help this move along. So we have done that for things like CSS Grid and lots and lots of features. So for maps, though, I think my advice, though, is that all of these things that I was just talking about apply. We have this problem of we have lots of maps, sort of, that have lots of commonalities, and it feels like there's a path there, but how do you map that into HTML? And it's very difficult. And which features should it include? And what is ultimately good enough? I think despite the fact that we have lots of experts and we have libraries and things like that, I think we don't know what's good enough until we try some things. And developers will tell us, like they'll know it when they see it. And it might be shocking what is good enough. HTML was certainly shockingly, good enough. There were better solutions before HTML came along. But also at the end of that, when we have an answer, it's important that it fits well into the platform and that it's self-aware of the pie it's asking for. So I think break it down and aim for the middle and improve the cost-benefit analysis, find unlikely allies, like find ways that we can deliver parts of it and share the pie that we're asking for. So one way to do this is to ask, what are the things that are making it hard technically today, and are those things only hard for you? And I would suggest maybe squint at it a little bit. There are very similar coarse-grained needs for like video game maps or maps of fictional spaces. If you want to, there are maps of Mordor, for example. And if you squint even a little bit harder, there are things that aren't maps at all that also have very similar needs. Product images for e-commerce is a really big one that people are interested in. Technical drawings. So basically, the web is lacking lots of coarse-grained features that we can do, and low-level things. Like pan and zoom is a great one. Lots of things need that. Off-screen canvas, maybe hardware-accelerated SVG. This is one of the challenges that we don't know what the necessary parts are yet. But I don't have the answers. I think there's probably a lot, and I'm here to hear your ideas and to see how I can help. So thank you.
I just want to say great presentation. It was very fun to watch. Good content too. Thanks.
Thank you.
Indeed. Thank you, Brian.
It was amazing.
Good way to start the day. We are going to continue now with something a little more map focused. Peter Rushforth is going to present in more detail what he hinted at the other day, the proposal he built for a MapML, a specific way of including map viewers in HTML using markup.
Thanks, Amelia. I'm gonna, I recorded my presentation, so it kind of auto plays, but that was a great presentation, Brian, and thank you very much for bringing your personal energy and effort to this, and we definitely welcome your words of wisdom. And we'll try to follow them. So I'm gonna go and share this and start my presentation. Thank you.
Good morning. In this presentation, I'll give an overview of the MapML proposal. MapML is a proposal to extend HTML in the HTML namespace to include elements and attributes that implement maps and layers. The objective of our proposal is to introduce a small set of HTML elements that will directly support maps and mapping applications with approximately the same authoring complexity as video or audio or image. Why do we need a map element exactly? We need a map element to provide a declarative semantic entry point in web standards for a few reasons. Above all, we need to standardize web map client technology because we should. It is the ethical thing to do. We need to make standard web maps learnable by children, not by binding such an important facet of human existence, not to mention survival, to proprietary frameworks. Having made that decision, we need a map element to obtain more efficient rendering of spatial content. Next, we need to define and standardize what accessibility means for web maps and especially web map content. Finally, we need to establish an organic, not based on metadata basis for spatially indexing web pages, so that search engines can return search results based not only on ranking the text of documents against search terms, but also based on spatial indexing of map elements in the page. Like the PageRank algorithm, but instead of or as well as backlinks increasing a hit's relevance, the page is literally nearer to the search term would raise the result rank. We propose to extend the existing map element by adding attributes and new child layer elements. The map element is a reasonable candidate for extension not only because of the element name, but mostly because of the element's processing model is already that of an interactive, albeit static map with layers, represented by the image and area elements. And the image map semantics potentially provide a path to scriptless, accessible, graceful degradation. This is the basis upon which other proposals to modify HTML have been successfully made, for example, the image source set attribute, among others. This approach also seems to be encouraged by various HTML design principles. The design principles aren't a license to propose changes to HTML, but they are a framework to help guide discussions. So if you have a concern about any of the design you hear about today, please consider joining the group and contributing those ideas. If we consider a diversity of viewpoints and experience, we will achieve a stronger proposal. The result of the proposed extension, whether it results in a map element or something else, should be a map widget or viewer that is designed for accessibility and is progressively enhanceable, in other words, scriptable. It's not the intention of the proposal to accommodate, by means of native browser implementation, all use cases of web maps today. It is a key objective of the proposal to expose DOM APIs, events, and other facilities such as styling that relate to loading, rendering, and using and creating map content. I've got more to talk about today than I have time for, so I'll cover some of the big ideas first. To begin, I'll talk about the key elements of the proposal, the map layer and extent elements. Then I'll spend time talking about tiled coordinate reference systems, or TCRS, because understanding those concepts is key to making sense of most of the proposal. Map projections define the coordinate systems in effect in the scope of the map, so that coordinates of places on Earth, or potentially other planets too, may be drawn on a 2D plane. Every map has a coordinate system that is shared by its layers. So, the proposed map element has a set of defined projection values. The default value, if unspecified, is OSM tile, which corresponds with Web Mercator. The set of projections is small, yet extensible, in the same way that, for example, HTML rel values are extensible, in other words, by agreement. I'm using the attribute name projection here as a user-friendly term to describe the concept that I call tiled coordinate reference systems, or TCRS. The term TCRS is defined in this proposal and represents a framework for naming and discussing the integrated concepts of tile caches, geospatial coordinate reference systems, and web map client concerns. Web maps all define their starting conditions, typically via a lat-long coordinate pair representing the center of the map. So the map element has required lat-long attributes describing its starting center point. On the web, as in real life, maps have scale. So the map element has a required zoom attribute which define the starting scale. This is actually a very important point and one that can go unrecognized. Web maps are, in fact, real-life maps in which paper or mylar has been exchanged for pixels. Everything that is represented must be represented according to an intended scale, including geographic features. The Boolean controls attribute turns controls on or off. Controls are created by default in a closed shadow root, like the video element. The controls list attribute can prune the set of native controls provided. We need a layer element to be a child of the map element because map layer is a primitive abstraction that is shared by many, if not most maps, both on and off the web. Layer elements represent map content, and each must share the coordinate systems defined by the parent map element's projection attribute. Map layers and their content are in light DOM in the same way that SVG content is in the DOM. Layers are added according to the painter's model in document order. Their label attribute will appear in document order in the layer control. Layers are children of the map element only and do not nest. Content can be inline or located in a document at the source attribute URL. A layer has a text label attribute. A checked layer renders on the map. A hidden layer is not shown in the layer control, but is rendered on the map. This can be useful for preventing the user from turning off important content and becoming confused. Layers can have inline content, as shown here, that is loaded and rendered by the browser. Web maps need a standard mechanism to load map data that does not involve knowing how to access server APIs beyond the strict uniform interface of HTTP. Browsers standardized HTML forms as a means to flexibly request and transmit data to and from any server within the constraints of the HTTP uniform interface. Web map server data comes in a wide and growing variety of formats and interfaces. This poses severe challenges for interoperability. So, we designed a mechanism for loading and accessing server information based on established patterns, for example, URL templates, and standards like WMS, WMTS, and OpenStreetMap Slippy tiles, and informed by the HTML form element. The extent element represents the part of a layer's content that binds to the viewport of the map. The extent element is somewhat analogous to the form element, being the parent of various inputs and links, the values of which are serialized during extent processing. Extent processing differs from form processing in that the user is not expected to fill in input values manually, because the extent, being bound to the map viewport, triggers content requests automatically as the map requires new content to paint. New content is typically required as the user either manipulates the map by panning or zooming, or the device by rotating or moving it. The rel equals tile value, shown here associated to tile-based URL templates, reflects a core abstraction in modern web maps, that of map tiles. The rel value tells the browser what the purpose is of the resource that it is loading. So, as the rendering engine iterates over the tiles that it needs, the browser fires events, which are serialized to variables identified by name. Each input variable binds to one or more variable references in the URL template links within the extent element scope. Once all the variable references are resolved, the URL template becomes an actual resource URL that is fetched and rendered. An extent can contain as many such URL template links as it needs to compose the map layer. In the example shown above, the geometry and labels of the layer are referenced by separate links. Tiled Coordinate Reference System, or TCRS, is a term coined by me to standardize and describe a system of talking about spatial coordinate reference systems from the web client's and user's point of view. When working with maps and spatial information, we inevitably need to talk about coordinate reference systems, and especially scale, and TCRS is my attempt to unify the vocabulary for coordinate reference systems so that this core concept can be made interoperable and teachable. Historically, geographic information systems have kept the concerns of map scale separate from those of the coordinate systems definition by maintaining intimate and detailed metadata about the coordinate systems of the data they manage, so that data can be interoperably combined or overlaid at runtime. Web architecture requires that resource metadata be encoded into media type specifications, so that runtime exchanges are not necessary or desirable. So, we needed to develop the TCRS concept in order to encode it into the MapML or eventual HTML specification. A TCRS has a defined number of integer zoom levels. A zoom level is an integer proxy for expressing a real-world distance units per pixel ratio, in other words, the pixel size, at a defined location, depending on the projection, typically the projection origin. The reason the set of zoom levels is defined and not infinite is because in some cases there isn't a mathematical relation between zoom levels. In other words, they're not necessarily evenly spaced as shown. They may have been chosen for reasons specific to the application and the fact that beyond a certain distance per pixel, it doesn't make real-world sense. By agreement and specification then, the zoom levels are defined and known. For each zoom level in a TCRS, there exists a pair of 2D coordinate systems in which the units are pixels and tiles, respectively. These coordinate systems follow the conventions of coordinate systems in computer graphics, having their origin at the top left of the screen, with the vertical axis being positive down and the horizontal axis positive to the right of the screen. The pixel-based coordinate system is called a TCRS with axes named X and Y. The tile-based coordinate system is called a tile matrix after the OGC concept of that name, and its axes are named column and row. Tiles are defined in 256 square aggregations of pixels, and the pixels and tiles are georeferenced by a defined planar transformation to the coordinate space, defined by the Projected Coordinate Reference System, or PCRS. The coordinates and units of the PCRS are defined by a mathematical transfer of coordinates to and from a defined Geographic Coordinate Reference System, or GCRS, according to defined parameters of the projection method. Two additional coordinate reference systems are defined to correspond with the same concepts from the WMS and WMTS standards. The map coordinate system is defined by the map's dynamic viewport and has its origin in the upper left corner of the map. The horizontal axis is named I, while the vertical axis is named J. This coordinate system corresponds to the image coordinate system in HTML's client-side image maps. It's also used by WMS getFeatureInfo requests to query server databases for features at a given pixel within a defined request. The tile coordinate system is created relative to each tile and also has I and J axes. It is created in MapML in order to support WMTS getFeatureInfo requests. Thank you.
Thank you, Peter. Lots of information there, but I hope it was enough to get people intrigued into looking more and the scope of the project. Our next talk is going to take another look at MapML, specifically more critical assessment from the web standards side. Simon Pieters has been involved in web standards and browser development for many, many years. He currently works for Bocoup, which is another sort of browser development, web standards development for hire company with a specific focus on testing and cross-browser interoperability work. And Simon was commissioned over past few months to sort of assess the MapML proposal as it is and how it can be moved forward. Simon, why don't you take it away?
Thank you for that introduction. I'm going to try to share my screen, so let's see if that's successful. Can you see my screen?
Yep.
Yes.
Good.
Excellent. So, hi everyone, I'm Simon Pieters. I'll talk a bit about Bocoup's review of MapML that we did earlier this year. So again, a short introduction to Bocoup. We're a web platform consultancy firm. We participate in ECMA, W3C, WGWG, and work on improving the web platform through specifications and test suites. We have experience standardizing both new and legacy features in HTML and CSS, also JavaScript, and writing corresponding conformance tests for browsers. So we can help with standardizing new features for the web and collaborate with the browser implementers. We participated in the OGC Testbed 16 program to review the technical specifications for MapML. So here are our findings and recommendations. We reported 21 issues for MapML, from minor to more fundamental. One of the fundamental issues is whether and how MapML should be an extension to HTML. My understanding is that it's the intent, but it's not really defined as such currently. If it is to extend HTML, then it should be done properly and ideally involve the maintainers of the HTML standard in the process. Another aspect is integration with CSS. MapML says that it should be stylable with CSS, but it's not defined how. I think CSS does not yet have the necessary primitives to represent web maps without resorting to solutions that are working against the browser, which is not ideal for performance or accessibility, as well as other aspects. We reported an issue for the CSS working group to consider adding a new panning and zooming primitive for use with web maps. This is one of the primitives or low-level capabilities that Bryan mentioned. Web maps have many possible capabilities that are missing from the web platform, but this is one that we identified. So the CSS working group discussed this in July and agreed that it was interesting to investigate, but they need a concrete proposal. So David Barron is from Mozilla, and said that it was interesting, but need a concrete proposal. And Tab Atkins is from Google, one of the editors of the many CSS specifications. Essentially agreeing that it's something that would make sense to solve, but there's no proposal yet. So again, going back to the extensible web manifesto that has been mentioned a couple of times, I think the approach that is more likely to have success in changes in browsers at this time is to start with specifying the primitives or low-level capabilities that are needed to layer MapML on top. Even if there's skepticism about adding maps to the web, people seem supportive of adding new primitives that benefit web maps. And this approach is in line with the Extensible Web Manifesto, which says to focus on primitives first and then develop high-level solutions in JavaScript using those primitives, allowing web developers to iterate without breaking the web. Another thing we think would be good is to better demonstrate the need for web maps in terms of impact for web developers. One way to do this is to ask about web maps in the MDN Developer Needs Assessment Survey, which is currently in the final stages of preparation. Last year, the survey had responses from 28,000 web developers, and the results impacted the prioritization for browser vendors. Our summary of work for this review is available at the URL at the top of this slide, bit.ly/Bocoup-testbed16. And that's all I have. Thank you.
Thank you, Simon.
Thank you.
And I'm looking forward to creating the discussion page, and we can get all those links in easily clickable form so people can go look at and comment on the issues. For our final talk on this theme, we're going to switch over a little bit. Satoru Takagi of KDDI has been building maps using web technology for many years now, using a base of SVG, and has developed proposals for what needs to get added to SVG to make it more web map friendly. So he and Peter Rushforth are going to be introducing some of the work they've done on that. Peter, if you're talking, we cannot hear you.
Yes, of course. Sorry, Satoru Takagi-san and a colleague from KDDI Corporation have developed 2 papers for this workshop, which are linked to their agenda item. And I promised Satoru-san to present the introduce these 2 papers that are very, very interesting and expertly crafted. And I promised to introduce them at the workshop. And I think that it's in particular well worth reading, because Satoru has been working for years within the, many years within the SVG community in the W3C consortium to standardize web maps using web technology. And I strongly believe that we share a lot of, fundamental primitive understandings of how the web works. And he has got some spicy commentary, spicy yet polite commentary in his papers. And the first of them is on decentralized web mapping. And it's very important to read them in order because decentralized web mapping sort of sets up the second paper. And in decentralized web mapping, layers are conceived of as a primitive feature of web maps and are accessible at bare undifferentiated URLs, just as in the MapML proposal. But in the SVG map proposal in this framework, the target of those URLs is an SVG document that links to an HTML logic bundle. And so each layer comes with its logic built into the actual document that is loaded. So what this means is that it can adapt, it's an adaptive framework to virtually any tiling system, proprietary or otherwise. And I think there's a lot of genius in that package right there. And that leads to the discussion of quad tree composite tiling and the standardization of tiling, in which Satoru-san has applied the techniques of SVG map to use adaptive quad tree tiling to vector information, which is efficient, very efficient. And so for raster data, standard tile systems seem to make more sense, plus or minus the different APIs that are used to access them. But for vector data, because vector data is meant to be efficient, an adaptive tiling system has real performance benefits. So I urge everyone to read those two papers and provide feedback and commentary to Satoru-san and his colleague, whose links are here to their GitHub profiles, but their discourse entry for their talk in the agenda is in the agenda. So that's all. Thank you.
Thank you, Peter, for the introduction. Do you have anything to add, Takagi-san, or just that we should read the papers? Well, we've all got the papers, and the links are in Gitter and in Discourse. I think then we will take 10 minutes to catch up on that and then start back up with our new theme and panel. Recording again? Take it away, Doug.
Great. Hi, everyone. Welcome back. Thank you so much for joining. Next up is our internationalization and security presentation. And following, we'll have 30 minutes, 2 talks in 30 minutes. And following that, we will have our panel, which is Worldwide Web Maps, Challenges in the Global Context. So with no further ado, I'd like to welcome Brendan Liu, who is going to be talking to us today about multilingual text rendering. And Brendan is he's a geospatial software engineer from no, I'm sorry, he's the creator of Protomaps, which is a new internationalization focused system for maps on the web. He's been working on map rendering and data tools related to the OpenStreetMap project since 2013. He also created 80s.nyc, a web map based viewer for historical street views of New York, which sounds really cool. Brendan, take it away, please. Brandon, take it away, please.
Awesome. I'm going to try to share my screen right now. So please tell me if that's working. Oops. I think it's one window at a time. Are you able to see that?
Yes, we can. Thank you.
Multilingual text rendering. Awesome. I'll get started then. So hi, everyone. I'm Brandon. I'm going to talk about multilingual text. That doesn't sound initially like it has a lot to do with maps, but I'm going to explain more about that in just a moment. So why text? I know this topic, this conference is mostly about MapML. I'm going to try to go a little bit outside of that scope for this short presentation and talk really about the essence of a map. So in my mind, a map has geometry in some coordinate system, but it also has textual properties. This might be data associated with map features. It might be map labels even. So even if things like putting labels onto maps are outside the scope of MapML, text is so essential to what a map is that it's worthy of forward thinking. And you might think about this like if you have a vector data set and you want to render it in the browser, you have to show the text in some way, whether that's Canvas or SVG or some fashion. And why do I care about this? A little bit about me. I work mainly with OSM. Right now, my projects are mainly focused on East Asia, which is going to be relevant to this talk. I'm building a new web map API called Protomaps. It uses the OpenStreetMap dataset. One interesting thing about OSM, it has a wealth of multilingual content. So it started in the UK in the 2000s, but it's now a truly global project. And I also want to say for this short presentation, it's going to have a very narrow focus on Han or Chinese script, which is only one part of global text. So I'm not going to get into text that goes right to left or South Asian scripts, for example. That's a huge topic, but I'm only going to focus on one very narrow thing. So sort of following the MapML proposed markup for data sets, I wanted to use this as sort of the illustrating example. Which is a data set that has two point features. One of them is Hong Kong, and one of them is Minato, which is a special municipality in Tokyo. These are just 2 point features. You can see they have like a lat long or long lat. They have some properties, which is the name in the native script and the population as a number. So this is like a pretty basic data set, just as simple as it can get. And how might it look on a map? So I just made, sort of these absolutely positioned divs on an HTML page that puts, these place names and data onto the map. And even if you don't read Chinese or Japanese, you might notice something interesting about this map, which is that these two characters are very similar. So the second character in Hong Kong and the first character here. And the interesting thing about this is that these are actually the same Unicode code point. So the design of Unicode is such that there's a range of characters called the CJK, Chinese, Japanese, and Korean Unified Ideographs. And these are glyphs, or not really glyphs, but these are characters that were unified between the different languages. So there's no way in the data set to actually know that one of them is, it should be rendered in the Chinese style and the other one should be rendered in the Japanese style. On the left here, you can see that there's a slight difference between these two characters. And these aren't really cherry picked. Like this, these variations are quite pervasive, especially in geographic data where certain components of characters have different conventions in how they're written. And Unicode was designed to be legible to users, where if you see a variant that is from a different region, it should make sense, but it is not really how it's written in that locale. The other thing I want to say is that place names are proper nouns. People might be more sensitive to how these are rendered than just body text on the web. And my main central point in this presentation is to push this idea that maps are inherently multilingual. They're not edge cases. Like we might think of documents on the web as being multilingual in some cases, like for language education or for travel. But I think the special thing about maps is multilingual text is inherent to any map that goes beyond just one national boundary, for example. So web standards have a lot of things to say about multilingual content. There's a link in this article, or there's a link in this presentation to this article that's why use the language attribute. So in HTML text, you can add a lang attribute, which has a BCP47 language tag to the top of the DOM, or even to any element within the DOM. So you can have an individual span or div of text, and that has a language attribute that will control how that text is rendered. So there's a very powerful solution that HTML already offers, which is to have element level lang attributes. And this is this kind of localization for text is supported directly by markup. Also, language attributes are needed for accessibility. If you wanted to have a screen reader, for example, that would pronounce text in a language, you need to know or have some tag about what spoken language is associated with that text. This is especially important for Chinese, Japanese, and Korean. So overall, there's this sort of tension between the document view of the world, like HTML, where documents have a language tag, versus maps, which is sort of a wild west of different standards or different libraries. And you can see on the web some map services, they have only one version for the entire world. And if they're rendered on the client side, they might still display the local name of a place. And I think that's sort of like a good target for globalization. Like if you have a map service in Japan, for example, that says Tokyo Bay, like Google Maps here, you still have the native language on the map, even for English speakers or users of the website that are using English. And I think that's like sort of a good convention that we have. So what's the state of these localization issues on web maps right now? Firstly, do graphics elements in HTML like SVG or Canvas support element level language tagging? How about web maps in general? If I go to, like a leaflet powered web map or Mapbox.gl or a vector map, are these language issues solved sufficiently? And how does this relate to web standards? For SVG, I sort of recreated that same HTML map with SVG elements. And you can see here that Safari, which I'm using right now, does not actually handle this. So you can see that these two characters are rendered the exact same way for different languages. You can see the code on the top here. It's two text elements. And actually, the only major browser to support element level language rendering is Firefox. So Safari, Chrome, and Edge, they just, they default to one language or the other. Canvas, for example, doesn't really have any localization features. There's no way to specify a language when you are saying this run of text in Canvas is global. There's sort of this global font property, and you don't have any control over the language. There is some proposals on enhancements to the Canvas standards to make this work. How about server rendered maps? Like if you're using MapML and you wanted to bring in a raster tile layer, sort of like you would use Leaflet for right now, it's sort of someone else's problem. On the server side, most common is to use a library like MapNick to render maps. And even MapNick right now does not have great support for these locale variants. This is something I'm actively working on. For example, OpenStreetMap, the main main tile set called OSM Cardo, sort of defaults to Japanese variants for Chinese place names, which is not ideal, something that can be improved. But how about client render maps? So client, like most state-of-the-art map renderers that are done in WebGL, they sort of skip this problem completely by shipping their own font stack. They use sign distance fields, which are really good for performance. They can be scaled infinitely, rotated. But this approach has very little in common with web standards, and it doesn't really reach parity. For some scripts, such as South Asian scripts, these map renderers don't really do a great job. The visual fidelity has some trade-offs if you're rendering complex characters like Chinese characters. So I think that web standards have a lot of potential to improve the state of the art. And you can see this in some hybrid map libraries. The one I'm focused mainly on right now is called Tangram.js. It was a MapZen project and now is by Linux Foundation, but it uses web standard text. it renders text to canvas first, moves that to the GPU, and shows it on the map. There's some performance trade-offs here. You can't resize text. I know OpenLayers has a similar design. I'm working on a new library called Protomaps 2D, which is vector rendering for leaflet. And in all these cases, off-screen canvas would be important to make these faster. As an aside, HTML video, which we've talked about as a sort of analog for making maps work well on the web, has an accompanying standard called WebVTT for subtitles. So subtitles are exactly this problem, which is how to present text on the web. And you can see here, I just have a video in this presentation. And I put in these characters, one attempted to be rendered in Chinese and one in Japanese style, and it doesn't really handle that. This does, however, work in Firefox. So WebVTT has an explicit element called QLanguage spans to mark up different languages inside of these subtitles. And that is implemented inconsistently across browsers, but it is part of that markup standard. I'm running out of time. In conclusion, my main point is that multilanguage or multi-script maps should not be treated as edge cases. We should think about multilingual out of the box for all map standards on the web. Text documents on the web with HTML have a good solution right now, element level languages. This has potential to improve the state of the art for web maps. Graphical standards, or anything that is responsible for presentation to the user, whether that's SVG, canvas, video, or a map element, should have those capabilities as well. So you can find me via email or Twitter, brandon@protomaps.com, or bdon on Twitter. That's all I have. Thank you.
Fantastic.
Really eye-opening.
Excellent presentation. Thank you so much, Brandon. Really a complex issue dealing with languages, especially when Unicode sort of folded them all into one block. Maybe that was a mistake. We do have a quick question. How could we support the same label but multiple languages and offer the choice? I assume that the question is to offer the choice to the user to pick one of the labels.
I think that would require mapping libraries to have some notion of user language, or it would need to be inferred from the user agent. But then that gets into very tricky issues. Like, for example, one common feature is for map labels to be sort of Romanized or transliterated into Latin characters for non-Latin scripts. And those would be common among different sort of Latin using languages. So you might need to have some kind of tree or fallback language that says, if I'm browsing a map in France and it has an English alternative label set, should I show the English one instead of French one if I don't have French, for example? And I think it gets into a very tricky subset of questions that maybe Web Standards is not prepared to have a complete solution.
Excellent. Thank you so much. That's a very thoughtful answer. And with that, it is time now to move on to our next presentation. Thank you once again, Brandon. Excellently well done. So next we have Thijs Brentjens. He is a geospatial software engineer. He's from the Netherlands. He is specialized in open standards in the geospatial domain and develops applications based on those standards. For Geonovum, he has been active for several years in developing national profiles of international standards. He has been contributing to the development of the INSPIRE, which is a European infrastructure for spatial information in the Netherlands and internationally. He's also active in the field of web accessibility for the geospatial domain and in usability. And his presentation today is entitled, Fuzzy Geolocation. Thijs, do you want to take it away?
Yes, thank you, Doc. Thanks all for this opportunity. I'll try to share my screen now. Let me see where my browser is. Please let me know if you're not able to see this.
Looks great.
Looks great, okay. Oh, my Zoom meeting itself is not looking that. Okay, just one moment, please. I have a list of participants in my screen, just in front of my slides. So sorry for that. I need to close that down. Okay, there we are. Yes, thanks. Thanks for this opportunity. I'm going to talk about fuzzy geolocation. I hope this concept will be clear through my sheets. But first, before I'm going to talk about this, how we are going to do this in the digital age, I'd like to give you a thought. In the age of analog maps, we were a user of a map was, let's say, he or she was alone in looking at the map, and who else than this user knew exactly what the user was looking for on a map. And I think you can imagine now in this new digital age for maps and online resources, a lot of logging or tracking, tracing can be done by a user or what the user is doing. So the context for this concept of fuzzy geolocation is that we have found out that digital applications use geolocation more and more. It's very valuable, especially with mobile applications. Your location is one of the main, let's say, characteristics sometimes for your personal environment if you're looking at some website or applications. And but there are many use cases where your geolocation, your personal location, may also be, it may not be that you wish that it is shared. For example, you want to use a web map and navigate to a doctor. You don't want to use your navigation system because you don't want some techno company to trace you. Or another one, a police officer is investigating some area. You don't want that this let's say extra attention is somehow locked somewhere, because it might be a security risk at some point, or it may compromise privacy. And it may sound a bit far-fetched, but in the Netherlands we have this. We have had a very big debate on COVID-19 tracing apps, and also that geolocation was not allowed to be part of it because of fear of people that their personal geolocation would be stored somewhere on servers owned by the government. So even this let's say this privacy awareness that many users have nowadays, it puts us for an extra, let's say, assignment. We have to do better in communicating our geolocation. So yes, I think we can do better. We should just not send an exact geolocation or area of interest to all kinds of online services. Just like we have, for example, privacy mode for browser tabs, or do not track me kind of things. Now it's very binary. You either provide your geolocation or you don't. But still, if you are using online data services, the area you are interested in is still communicated over two services. So I think, and this is an idea we had within Geonovum, originating from this COVID-19 discussion as well. We should do better. And the thing is, how can we do it? And I'm now going to present a sample or an example of an interaction pattern, how we could maybe improve this. But I'd like to challenge you in sharing other ideas as well. So this is the concept of fuzzy geolocation we have been talking now in Geonovum. For example, as a user, I'd like to have a map around this specific location you see here. It's very low around my house. Currently, this location is directly sent to some online service. I'm getting a notice here that my internet connection is unstable. Am I still? Is still clear?
You look and sound.
It's okay.
Fine.
You look fine.
Okay.
The audio was breaking up a little, so if you have any other apps in the background, that closing them sometimes.
No, there shouldn't be anything.
Stopping your video.
I'm afraid of is that my children are looking a movie now, but that's sorry for that.
Maybe stop.
Yeah.
Thijs, maybe you can stop your video.
Yeah.
But otherwise, just go ahead.
Okay. I hope my slides are clear then. Okay. What we can do, instead of sending the area of interest directly, we can also change maybe the center of the map, or enlarge the area, or add random other areas before we engage other online services, and use this kind of pattern to retrieve information from APIs, and then with some post-processing, go back to the end user and filter out only the relevant part for the end user. It puts a burden a bit more on some APIs or online services, so we realize that, but as a thought, that this might help in, let's say, putting a more privacy secured, or at least not compromise privacy that much. So this fuzziness, it can be added by, we think now, at 2 points. For example, by a trusted third party, a broker that adds all kinds of smart algorithms or smart ways to add fuzziness and do all the communication with online services. And it can also, a broker can also provide additional services. For example, cache other map resources, add random requests, or maybe fake users to not make clear where you are at that point. Another approach might be that in mapping clients, or maybe user agents, or maybe in browsers themselves, there may be smarter ways of preparing requests before you engage online services. So these are some ideas we have now, and I'd like to conclude this with an invitation to collaborate on this idea. I know this community I'm presenting for now is quite diverse. And I hope that many of you have ideas how we can help or improve privacy and security for these kind of geospatial applications. Our organization will create a proof of concept. We will share all the resources. I will put them on Discourse as well, put pointers to them. We will provide some OGC APIs if you need them and you want to try some things yourselves. But the main thing is I'd like to ask you to share your ideas, your criticism as well, and help us in improving this idea. I'll provide you my contact details later. We are also available to help. As I said, we will provide some OGC APIs that you can use for testing or to demo the concept. But if you need any other help, please contact us, because we think that this community might be a very nice and powerful community, and we'd like to bring this further together. So that's about what I'd like to talk to you about fuzzy geolocation and privacy. I hope my message came across and that it was not disturbed too much. And I hope to hear from you.
Thank you, Thijs. That was a really interesting presentation. I was able to see everything fine. I don't think you need to worry. This reminds me of things like Tor and other sort of obfuscation techniques that have been used in non-map non-map domains. So it seems sensible to me. Let's see if there are any questions. Let's see. What is the path that you recommend to see this done? Should there be an OGC geolocation privacy / fuzzy API? Should there maybe be something in W3C? I know that W3C tackled this or tackled some of the controversy here when they added the geolocation API to the browser. So what do you think the path forward is? Do you think this is something that goes in the browser? Do you think this is a protocol thing? What do you think?
Good question. In fact, I don't know yet. I think one of the things is that we need to find out what's the appropriate place or where to tackle this. But it might not be a discussion whether we should do it either in the browser or using some kind of other protocol. It might be end-to-end as well. I think for the, let's say, the maximum reach out, I think it would be best if browsers would support some kind of pattern to add this fuzziness in geolocation. But I can imagine that for some organizations, they are looking for other security measures, and they will have their own, let's say, their own brokers themselves to be sure that they are in control of what is sent to other services. So let's find out together, I'd say. But
someone else notes that asked the question: could the user agent provide this in a private map mode? In other words, in an incognito mode, could they could communicate that? So maybe it doesn't. It isn't an always on thing, so it doesn't always do the. But if you're doing something like Tor, for example, if there are enough queries, could you actually aggregate them through a third party and sort of allocate who gets what information based on this aggregation, sort of like the multiple users doing that? I didn't frame that as a question. Do you want to? Does that?
I think the most powerful options will be in if we use let's say brokers somehow. Yeah. Because then we can add all kinds of additional services. You can, if you do it in a user agent, there's always the trigger or event coming from a user agent. And if you do it using some kind of a broker, you can even add. That's what I meant with fake users. Or if users are not using it, you can still interact with services, or you can do caching, or and with all these more modern APIs and vector tiles, it may be easier to build such a system.
That's great. That's really.
What's a thought? It's not.
Well, again, everyone, both Thijs and Brandon ask you to reach out to them. So if this is a topic that interests you, please make sure to talk about it in our various channels for the workshop, but also reach out to them directly, and we'll and hopefully some good things will happen from the presentations. Both really great presentations. Thank you so much. And I'm going to have the pleasure of joining you, having you join me again. We're going to start the panel now. So the panel today is called World Wide Web Maps, Challenges in the Global Context. And I'm going to reintroduce Brandon and Thijs, and there's two other participants as well, Siva and Nicolas. And so let's get started right now, if that's all right. So let's start with Thijs. Thijs, you're already here. Again, Thijs is a geospatial and software engineer from the Netherlands. He specializes in open standards in the geospatial domain and develops applications based on the standards. For Geonovum, he's been active for several years in developing national profiles of international standards, and he's been contributing to the development of INSPIRE, which is the European infrastructure for spatial information in the Netherlands and internationally. He's also active in the fields of web accessibility and usability in the geospatial domain. So Thijs, do you want to give us any additional words? You seem to be frozen. Or,
I'm frozen now?
Nope, you're unfrozen now. Go ahead.
Oh, okay. No additional words. That's my video, maybe it's better.
That's better. Okay. Thijs, do you have anything else to say about what you're doing?
Oh no, no, I've nothing else to add for now. No.
Okay, great.
Thanks for introducing again.
So to reintroduce Brandon, Brandon is the creator of Protomaps, which is an internationalization-focused system for maps on the web. He's been working on map rendering and data tools related to the OpenStreetMap project since 2013. He also created 80s, that's 80s.nyc, a web map viewer for historical street views of New York. And Brandon, do you want to say any more about what you're working on right now?
I don't have anything to add, thanks.
Okay, wonderful. Okay, next we have Siva Pidaparthi. Siva is a a software developer working at ESRI with a focus on mapping and visualization, building desktop applications and dynamic mapping services on the server. He works with design and development, OGC-related mapping services in desktop clients, REST-based services and clients, and web maps stored as documents online consumed by various platforms. Siva, can you say hi?
Hey. Hi, everybody. Can you hear me?
Yep, we can hear you fine.
Good. Yeah, thanks.
I was just told that my internet connection is unstable. If I drop off, y'all know the questions. So, and I also sent them to Peter Rushforth, and hopefully, if something happens to my connection, Peter can step up. And finally, we have Nicolas Palomino. Nicolas is relatively new to mapping. He's more focused on the subsystems underlying the development of web maps and their utility for the industrial uses like big data manipulation and observation, advanced analytics and AI integration, and other upcoming telecommunications technologies for planetary observation and beyond. Nicolas, do you want to say hi?
Yeah. Hello.
Okay, cool. All right, wonderful. Hey, y'all, excellent. Let's go ahead and get started. The first question we have is, OGC and W3C have spatial data on the web best practices, and OGC is very actively working on new API specifications that could facilitate better publication and easier use of geospatial data. But that's the theory. How do you think we can put this in practice on active projects? And y'all can just jump in. Everybody's free to answer the question. Do we want to start with maybe Thijs?
Yeah, well, I think this is an interesting one because on the one hand, you would say these APIs, they are quite new and there might be large interest, but what we see currently, at least in the Netherlands, is that there's not that much interest in really implementing them because of legacy concerns. But one driver could have been that on a European level, we have a law prescribing what kind of technology to use to exchange information between countries. And I don't know if this is solutions, but this might be, I think one of the aspects is that especially for governmental organizations, we might need stronger policy on using APIs on technology. And I think there are many challenges there, but that's one of the things I'd like to propose. And of course, doing experiments in live environments, but that requires other organizations to,
okay,
of course, to step up.
Siva, Nicolas, Brandon, any thoughts?
I'd like to pass.
Okay. Nicolas?
I pass on this one too.
Okay, great. Brandon, do you have any thoughts on this?
Yeah, I think one interesting thing about sort of spatial, especially for open source spatial, is that I think the landscape really is not that large. Like a lot of sort of developers are working with PostGIS, and to have or fund sort of a reference implementation or a driver for some of these major spatial projects, things like PostGIS, that in QGIS or and also Google, I think is having a good implementation that makes it into, like a release has a big impact. So I think like it's sort of an advantage that it's not like JavaScript frameworks where, there's 101, there's a new JavaScript framework coming out every day. I think a lot of this sort of open source spatial world is quite stable. So having a reference implementation in those is a pretty reasonable target.
Okay, great. Yeah, that makes a lot of sense. Oops, stop. Okay. Apologies, I'm just timing you. And my clock went off. And you had perfect timing. Okay, so the second question I have is, there are many localization features of maps that would benefit from browser support. Some examples are the ability to produce place names in the writing system that the user can use, as we saw earlier in Brandon's presentation. Designing or authoring a multilingual map based on the locale. Handling dynamic formatting of numeric or time-related data, and other interesting cartographic practices from around the world that aren't yet widespread in digital map making, like vertical text, which is supported in some aspects in the web, but how often is it used in web mapping? So what should web browsers and web standards do to provide solutions? And I'd like to start with Siva here. Siva, any thoughts?
Can you hear me? Yeah.
Yes.
Yeah, sorry. Yeah, I liked Brandon's presentation on this topic. The only additional thing I wanted to talk about in that respect is if I, as an author, want to support multiple languages within the same map, then I should be able to advertise or provide the metadata of what the languages are that this particular map supports. That way, the browsers will allow the users to pick which language to use, for example, instead of just locking to one specific language that the browser is pointing to. So yeah, those were some of the thoughts I have. I always deal with the dynamic rendering or like the server-side rendering aspect of it. But I think for WMTS, for example, you could potentially use the style, for example, for language, but you'll have to come up with some kind of a formalization of this language feature within the metadata for the WMTS, for example. Then you'd be able to use style or other template parameters for language, for example, where you could make a given map multilingual.
Yeah, that makes a lot of sense. Nicolas, do you have anything to say on this one? If you do, you're muted. If not, let's move on to Brandon.
Are you able to hear me?
Yes.
Okay, cool. Some thoughts on maps and languages. I think one thing you see common on web maps is, I think I mentioned this earlier, but transliteration of place names. For example, if a place name is in a non-Latin script, then the backend might provide, a Latin transliteration, which should be able to be served to all users that use Latin scripts. Now, like in that case, that's kind of open-ended. If you look at how BCP47 language tags are structured, you wouldn't want to specify every single, German, French, English, all those. But there might need to be some intermediate sort of like script tag that defines certain languages as as using certain writing systems. Now, I haven't thought about this a lot, and there might be some fatal flaws to this approach. But I think that would get you part of the way there in terms of being able to show maps to users in different locales. Now, how much that interacts with web standards, I think is a tricky question, because I think for something to become a web standard, it's not good to give like a half-baked internationalization solution. Like it's not good if the internationalization solution is just a minimum viable product that only works for languages that go from that only works for left to right languages, for example.
Right.
So I think like there needs to be a lot of care in pushing something as a standard versus having a low-level set of tools that can be used to accomplish something. And I think that's like one of the overall tensions between talking about MapML versus here's a bunch of JavaScript, do something with it.
Sure.
So I think that is, I don't really have, I guess, the knowledge to know what the right approach is here. The second thing I want to talk about that I mentioned is things like vertical text. That's something I added to the question list. It's something that I really like, or it's a topic I'm interested in. And I think the browsers have a lot of good progress in making that work well on the web, even though it's not used. Like, for example, for CJK, it's common for for print typesetting to use a vertical text. On the web, sort of the status quo is for text to always be horizontal. It would be nice to have that as something that's well supported in web maps. For example, if you look at print maps that are published in Chinese for features that are mostly vertical from the perspective of the viewer, they will label those vertically. And that's like a very common practice in print maps. But on the web, there's only a couple of rendering libraries that support that. So I'm curious if there's some way that the things that have been built for web browsers already can influence more cartographic possibility for web maps.
That's definitely an area where we need to look at what the standards are already doing and what browsers are already doing, and have that inform what we're doing with maps.
It's such a deep rabbit hole though, because a lot of web maps also need text on curved paths. And that's something that that's something that people want for SVG, for example. I'm not sure what the current status on curved text.
I can tell you that curved text does work for SVG. So bringing that into, and that works across browsers. So bringing that into it should be possible. I'm gonna ask Thijs if he has anything to jump in here.
I have nothing to add. No.
No. Okay. I'd love to go in further, but we also have more questions. This is a fertile topic for conversation. So the next question, thank you all for those thoughtful answers. What are the challenges for security and privacy for personal geospatial data in an international context? And Thijs, can you start with this one?
Yes, well, for those who heard my presentation before, I think the main challenge in the end is that we need to get it between the ears in our heads that privacy and security may become, all the benefits we have with geospatial data, they may also have we have to pay a price for it with privacy and security. So that's maybe the main challenge. And then it comes down to how can we act upon it. So I'd say propose experiments, but also share ideas. And maybe like you have, if you do a security tests for web applications, you have this list of OW, ASP, OWASP. I'm not sure if I pronounced it correctly, but these are just checklists. You need to check whether you comply to them or not. It gives them new ideas what you can do for security and privacy. We don't have that, as far as I know, for geospatial applications. And I think that's one of the things that in an international context, we might try to work on, create such a list.
Right.
And then, of course, we have the technology implementation, etc. But it should also start with creating all those kind of risks and identifying them and share them and help each other out with that. Get in the awareness, I'd say.
Absolutely. Siva, do you have anything to add here?
No, I don't have anything much.
Nicolas? Okay, Nicolas, we're not hearing you. If you okay, and Brandon, do you have anything to add here? I hope we still have Nicolas online.
Nope.
Okay, great. Yeah, this is definitely a topic with internationalization touches on law and ethics, privacy, security. All of these things are multifaceted international issues. So the next question we have here is Web Mercator is a de facto standard for the web, but has flaws, for example, like Pacific-centered map making. What's the right balance for web standards in making these choices for users and developers? Who wants to start off here? Siva, Thijs, Brandon, Nicolas?
I'll start.
Sure, thank you.
Yeah, I think maybe it's a little bit of a gut reaction, but I think to sort of privilege WebMercator as, you know, the first class frame of reference for web maps, I think that might get some pushback from parts of the world. Especially like, you know, just like, because I think the truth is for a lot of like map presentation layers, they will say, if you have features that cross the anti-meridian, you need to pre-process them so that, you know, like those features, they only go to, you know, from whatever to 180 and then from negative 180 to whatever. And I think that it's a little bit tough because I feel like the number of applications that are affected by this issue is large, and the solutions are really non-trivial. Because the solutions is essentially like, you might author your GeoJSON to have coordinates that cross the anti-meridian, but then in order to make it work correctly, you need to bring in a library like turf.js that, you know, slices up your features, for example. And that's already like approaching a level of developer sophistication that is not as simple as just putting some markup on a map. So I think the entire issue of map coordinates, it does demand an inherent sophistication, like mathematical sophistication, that might be a hard sell for this imagined audience of, you know, every web developer in the world can author, you know, spatial content. I don't have a good answer. It might just mean that we need to you know, suggest a set of libraries to do spatial operations in the browser. I'm not sure if anyone else has suggestions on this issue of map projections and, you know, different centers of projections. Like if you wanted to have a Pacific centered Mercator, maybe just adding that other option might be a possible solution. I'm curious what other people have to say.
I think MapML tries to address this by actually having some projections built in. So that's some ground for thought. Siva, Thijs, anybody else? By the way, folks, I apologize. Nicolas is apparently having some sound issues, unfortunately. So if he has an answer, he's just going to type it to me, and I'll read it out. But I apologize, Nicolas, that this isn't working for you. Thijs, Siva, do you have any thoughts about the web Mercator?
Thijs here. I think I really like this topic as a discussion topic because it's a very hard one to crack, is not? And what we see now is that many people and children growing up with web Mercator, they think that Greenland is maybe as large as Africa is as a whole continent. You know, so it may distort even the image we have of countries or whatever. So I think it's a very important topic, and at the same point, just as Brandon pointed out, it's very hard to explain to others not in the geospatial, not working as a geospatial with geospatial knowledge. Projections are hard, and especially if all kinds of libraries support mainly a web Mercator. If that's the go-to projection, and you need to finish off a project very quickly, that's what you do. All kinds of resources are available in that projection only. So I think there's a major challenge, and can we find a reasonable alternative for some use cases somehow? And are we able to get all kinds of software working that easy that we can use these alternatives as easy as we can now? I don't have a real answer to that, but I think it's a very important topic with more impact than just, let's say, a mathematical discussion.
Yeah, absolutely. It definitely goes, I mean, this definitely goes to a social justice and international and inclusiveness issue. And if anything, hopefully what maps will do is bring people together around the world. We have one more question we prepared. I don't see anything from Nicolas here. Siva, did you have something to say, Siva?
Nothing much. The only thing I would say about that is like, when we are looking at new standards, we should also be thinking about other coordinate reference systems, not just WebMercator or like WGS84 or whatever, right? Which are good for the global data, but for local, they're not very good. So I think it is just a mindful kind of a thing where, we should just take care of additional coordinate reference systems into the account. Yeah.
Yeah, I really like the idea of perhaps promoting some other non-Mercator projection that could maybe catch in the public imagination, so it could be easy for people to not just easy for them to do, but easy for it to be top of mind for them.
Exactly.
That could be helpful. Finally, the last of the prepared questions. So W3C is a leader in accessibility, like, for example, the Web Content Accessibility Guidelines. And accessibility is now demanded by law in several countries, but it is difficult and often not taken seriously to apply these guidelines for mapping and geospatial data. I'll note that we have 2 upcoming panels later in this workshop on accessibility, but in an international context, do any of you have any thoughts on how we could make this easier? Siva, I'll start with you.
I come from a desktop world, where the standards are pretty standard, I would say, in that sense. And we comply to a lot of these standards and we pay attention to it. We make sure every bit of UX we have works well. But I can understand how this can be complicated for a browser or browser applications, which has to deal with lots of generic, controls and implementations or elements, basically. Yeah. That's all I have to say. I don't have much expertise on the web side of it.
Okay.
Yeah.
Thijs?
Well, to me personally, I think this is a very important topic. You see it on W3C conferences that the attention for accessibility it's there, always there, and it's not in the geospatial world. And there's simply this idea that maps are visual and it's the only visual. It's just what we do. You can't make that accessible, so we just don't do it. And I think there are again, maybe we should share more ideas of what we can do to make things accessible, to make maps and the information on maps accessible. And it requires us also to maybe do a step back and think of what maps are, just as a representation of some data. And there are other ways for that. They may not be the ones you prefer as a geospatial developer, or they may not be as user-friendly as you might think. But I think we need to discuss that more, and also try to have common libraries, as Brendan pointed out in an earlier question. Common use libraries. We should try to improve accessibility in these libraries.
Right.
Those are things I'm thinking of, but I'm for sure other experts in this workshop are there. They have a lot of interesting things to say on this, I think. But it also starts with the idea, breaking down the idea that that maps are not easy to make accessible, because I think there are options. And
okay, well, we're going to explore some of those options later on in the workshop.
Yeah.
Brandon, do you have any thoughts, or Nicolas? If not, we have another question. Oh, Brandon, did you have something to say? No. Okay.
Thanks.
Yeah. So we have we have actually several questions, and we only have 4 minutes left. How are context menus handled internationally? And I think this came in, Brandon, while you were talking. So maybe, do you want to handle that first?
Context menus, is this specific to HTML?
I don't know. I think it's really thinking about. I'm not sure exactly.
Well, I was thinking about the maps, or we have a layer control, and there's some, you have to have internationalization considerations in providing a widget. So there's going to be, like challenges involved there. So I just wanted to see what
You mean like vertical versus horizontal, Peter?
Yeah.
Oh, okay.
Right. I think the good solution is just to say anything that, like that's just an HTML subdom within that thing that's rendered. I mean, that's the approach that I think Leaflet takes, is you can just put whatever you want inside of an element that's rendered on the DOM. And if that's a spec, you know, I have no idea how hard that is to implement, because that seems like you could get into a lot of pathological cases. But it seems like that is the best internationalized, that's the best internationalization solution, because anything that is capable with regular HTML can just apply within that context menu. I mean, that's ideal from my perspective.
We actually have, Nicolas said, I'm going to read his reply here for question 3 about privacy. He says privacy is one of the most important components of the system. He doesn't know what challenges exactly it could bring as we actively apply such applications, because laws differ from country to country. Another important thing, I think, is that this could be possible, could possibly generate a large amount of data. So it turns out this data could be a matter of national security as well. And that actually leads into another question that we had, which was from Fred Esch. If we have the time in a global challenge, if we have time, in a global challenge, how do data costs and performance get factored in? Siva, have you, has ESRI looked into this? Have you thought about this?
Yeah, I'm not much on the content side of the things, so I might not be able to answer this. Yeah.
Okay.
Yeah.
Any of the rest of you have thoughts about that?
Thijs, sorry, I don't fully understand the question or the.
Well, Thijs, I think I think you kind of touched on it in your presentation.
Data. Okay, the amount of data we may, or amount of burden maybe.
We only have 1 minute left, so if you can just keep it very brief.
Okay. I think it's a challenge, but if you use, for example, smart caching systems, you might be able to reduce load maybe on some other services as well. But in the end, adding all those kind of extra things will add asks something extra somewhere.
Right.
Either in processing vector tiles, either in, you know, it will be at some cost.
Y'all, thank you so much. This has been great. Thank you all so much for participating in this panel. Sorry for the technical snafus, especially to Nicolas. Thank you everybody for attending or for watching afterwards. And I hope that all these conversations come back around. Please contact the individuals who participated in this if you have thoughts, either in the workshop or afterwards. And thank you so much, and have a wonderful day.
Thank you. You too.
Bye, all.
Thanks, everybody.
Thanks. Have a good day.
Okay, we're sliding into one of our breakout sessions. Peter and Gethin, do you want to set that up? I think we're just going to continue using the same chat. So if you're interested in extending GeoJSON for web applications, please stay on. We've got a couple talks on that topic.
Over to you, Gethin.
Okay, thanks very much, Peter. So welcome to the first breakout group, I believe, of the workshop. I'm the curator for digital mapping at the British Library, and we've got a couple of presentations from people that work with cultural heritage data now. I believe that this is a valuable perspective for the workshop in a couple of ways. First, it was really interesting to hear about people's thoughts about Mercator projection earlier. Being a curator interested in the history of cartography, you know, I believe that it's really interesting how ubiquitous that web locator projection is. And I think that looking at cartography can help us understand projections going forward. But also second is the use of, in cultural heritage, we use web maps a lot to present collections for discovery and interpretation. Now, here we have developed a lot of open standards, and within our relatively small community, that's led to good data alignment. And so we're going to just talk about a couple of extensions to GeoJSON that we've been working within in that community. And we're not suggesting that these should be added to the MapML spec, but we are interested to hear about views from a broader community here related to these developments, and see what the reaction of a wider audience will be. It is a breakout group, so these are going to be quite short presentations. And afterwards, we're hoping to elicit a discussion in general about the relationship between MapML and GeoJSON. And we'll be taking, suppose if the organizers can put me right on this, but I think in the initial instance, we'll be taking questions in the Gitter channel. I think there's, you know, the number of participants is quite manageable. So if it is meant to be a breakout group, so if it's okay with the organizers, if participants did want to mention in the Gitter channel that they had something to say, perhaps they could unmute themselves and speak as well. Is that okay?
That makes sense. I mean, we've got 16 people on the line right now, so we can probably just open this up as a chat. After
okay, good.
Presentations, of course, to start it off.
Yeah, that makes sense. Yeah, so there'll just be a couple of short presentations. First, in cultural heritage, we deal with cultural information. And so the nuance, uncertainty, and really the humanity of these data are not peripheral concerns. Representations of place can be at odds with positivist systems like coordinates. And so that's led a lot of work to focus on open data modeling using EF. The semantic structure here offers flexibility and complexity, the ability to model flexibility and complexity. But this isn't without drawbacks either. And so now Bryan Haberberger, who's a full stack software developer at the Walter J. Ong S.J. Center for Digital Humanities at St. Louis University, is going to talk about this topic and his work on expressing GeoJSON as data 1.1. Thanks, Bryan.
Thanks, Gethin. Thanks for the intro. Hi, everybody. I'm going to stop sharing my video and share my screen and hope that kind of helps keep things smooth. So let me get going here. Can you all see my screen?
Yes.
Great. So again, my name's Bryan Haberberger. Along with being a full stack developer at the Walter J. Ong S.J. Center for Digital Humanities, I am also the IIIF Maps Technical Specification Group Chair, or one of multiple. And what that group is doing is sort of working within the framework they have set up, which is very based on JSON and JSON-LD, and allowing a way for standardized coordinate assertions to sort of enter the fray. So why linked data? I think Gethin gave a good intro about it, but essentially the semantics allow for interrelated data sets on the web. So if I have a data set that describes people, places, and things, and you do too, I would like to be able to pull some of your vocabulary and direct meaning and use it to express that in my data set. And in that way, we can sort of enhance each other's data sets and encourage each other for the well-encoded data for the future in the cycle. And so there's linked data, linked open data, linked open usable data. It's all essentially the same, but in settings where the sources are open sources, that's when we say linked open data. And usable is always just a hopeful, but we like to use that word. So how does this connect with GeoJSON-LD? We're not going to talk about the GeoJSON-LD spec directly. Instead, what I'm going to talk about is the linked data, vocabulary, and context that have been created for it. JSON-LD is a W3C specification, and like we just said, it recently had an update. As you can figure out, GeoJSON is JSON, and so there has been work to make a GeoJSON-LD context that's compatible with the JSON-LD 1.0 version. That's sort of what allowed GeoJSON data nodes to be a part of the linked data system going on in all the things we use. So one important thing to note about GeoJSON-LD is that nested GeoJSON coordinate arrays are incompatible with the model. I'll show you exactly what that means and what that means for functionality here in a second. But sort of at a top level concept, what this means is GeoJSON-LD is unable to express polygonal shapes. Not that it can't, but rather that when it does that, it's not able to process it as LD. And so applications that are specifically trying to be LD ignore what they can't process. So that would mean all of your polygons would be ignored, which is a massive problem for geography. I'd assume you'd all like to be able to use polygons. So the LD 1.1 release, the most important thing that came about it was that it allowed for list of list structures so that things can actually be rendered. So I'll just give you a real small demo here real quick. Hopefully, if the internet will allow it. So here's the JSON-LD playground. And if I come in with that data, you'll see right away it tells me this is not a valid syntax. I can't do lists of lists. What that means sort of exactly is laid out a little better in the spec to tell you why they chose not to do that. But as people started specifically to work with GeoJSON and GeoJSON-LD, it became clear that the list of list structure was going to be necessary for data. And so that's when the LD 1.1 spec came out. And just to show you that I'm not kidding, it now specifically states that lists of lists are fully supported. So what that means is we would hope if I came into the LD 1.1 playground, that if I put that data in, it would successfully process, which it does. So just a super fast overview of what linked data does. You can see in the GeoJSON, we use terms like properties, geometry, type, and coordinates. And those are all directly mapped to a vocabulary or a specific definition that allows the keys to understand exactly what they are. So you can see by geometry, I mean what GeoJSON says about geometry, and so on and so forth. And you can see here how it successfully can do, I'm a list, I contain a list that has a list, and that can go on forever. But it's obvious that is allowed now. So that's mainly what I wanted to show you here. And then of course, I'm sure you want to see it draw. So if we go to the GeoJSON validator with that object we just had, and we paste it in and test it, you'll see that it draws my shape, and it's my very crude bounding area for the Eiffel Tower. So we know it's GeoJSON compatible, and now we know it's LD 1.1 compatible. So we sort of have a way to properly describe these data sets using linked data. So now I'm going to talk about another W3C specification called web annotation, and specifically how that connects with web entities. So as I talked about earlier, I work in a digital humanities center, and we are more of a dev shop than a content shop. We actually don't hold a lot of content. So what my use case is I need to be able to add descriptive information to content that's owned somewhere else and still be able to use the data connected with that data node that I'm targeting. Trying not to go too much into it, I think it's a lot easier if I just show sort of a pipeline for what that looks like. And I'm sorry for clicking. So let's say I know a repository, a portal, as we've talked about earlier, that I can go to look for resources. Stanford has one of those, and it says that its resources are IIIF, so we'll go to something recent they had, and it's Black Lives Matter Memorial. And if I go into it, if the internet will load with me. You'll see that it loads up here, and it has the images that go along with it, and probably other information about it. I can specifically just ask for the data object that's in the background of this. So if I do, and I just happen to know to use this because I work with these guys, so I know how their portal works. You can see the object in the background. This is very IIIF. I'm not going to go into it too much, but they have context and everything to sort of describe their keys in terms as well. So if I bring this manifest and I say, I would like to say, I know where that manifest is at, I can bring it in here and say, that's the URL I want to use. There's the object we know that it is. And I know it's somewhere over in California. So I'm just going to kind of guess. Sure, probably not there, but let's go for it. And so what that does is generate a web annotation that connects that resource to the coordinate properties. And you can see here the body of the web annotation is GeoJSON. And so these contexts combined mean this works as a 1.1 web annotation, and in particular, because of some dumb luck, this context actually has at version 1.1, which means process this as LD 1.1. And so the GeoJSON context, which does not contain that, sort of gets it for free, just by properties of how combining contexts work. So now if I go ahead and create that annotation, great, it says go see it in Leaflet. So I'll get to what that is in a second. So you can see there how I just provided a target, made JSON body for it, and made them relate to each other. So now what I can do is ask data sets that I know are doing this to just supply me with all of those coordinate assertions they've made. And when I do, they'll show them here on a map for me. So these are just those web annotations that I pulled out. And here you can see I never supplied a label, I never supplied a description, but the target data had it. And so I can just resolve that target lifetime and show data about that target lifetime without ever manipulating that data directly. So if anybody changes the label, if I refresh this page, we're going to see that new label. And that's sort of how we realize our pipeline. We don't have the content, but other people don't have the developers or the annotation systems to describe their content. How can we all still, work in that process? And so here's what I just showed you. This is what it looks like. And you can see here, instead of using the IIIF presentation context, I use the web annotation context. The IIIF context contains the web annotation context so that I don't have to include it as a third one. Sorry. I'll show you just super fast in a linked data context how you might go about doing that. Oh, that is the wrong one. I'm sorry. My fault. So you'll see here they pulled in description for an annotation collection, an annotation page, and an annotation, and say I use their context, but, and as we just described about in the internationalization problem, IIIF really deals with international labels. And so they needed to define a way to say, I can provide multiple labels of a certain language, more descriptive than just the label that web annotation wants to use. And so how that gets realized, one of the things the IIIF Maps community group is working on is providing recipes for making these kinds of assertions. And so you'll see here how we actually have to make the label. It's not just label : string, it's actually an object containing arrays of information attached to language, which is what that LD context told me to do, so that I know as the developer now to make my labels like this, so that the viewers know to grab them and show them based on the language they're in. It's just sort of an example of how linked data tries to connect that entire pipeline. And then down here further, like I've shown you before, here's what it looks like. The IIIF API uses annotations, and inside those annotations are web annotations. So what this is right here is an actual web annotation with its own coordinates that are outlining a city to sort of fuzzy locate what resource is being described here. And that was sort of how we realized that pipeline. So these recipes are up, and it's something you can go look at. I've got notes included, links included in my notes and with the slides when we get there.
Right. It's now 1:15, so could you wrap up, please?
Yes, so that was actually the end of it. So now yeah, I know, I'm trying, Gethin. So now the future of GeoJSON, IIIF Community Group is working to take that specification and get it somewhere where it can be maintained, and we can add things like the @version 1.1 property to the context to make this 1.1, because we think GeoJSON will continue to be used and absorbed like standards being promoted in this workshop, and it should continue to have definition for it on the web. And that's sort of our charge right now. And I think the next piece is what Karl, the next speaker, is going to talk about, is extending it even further to maybe include other dimensions, and then hopefully being able to take the sort of format here as JSON and realize it as a markup language and ways to connect with like WebML. So that's it. Thank you.
Okay. Thanks, Bryan. That's a great explanation of how we can use these web annotations to make assertions about documents on the web, and those can take, through use of a predicate, those can take a variety of forms. So for example, if we're talking about a place, we can say this is within, on the edge of, outside that place, and attach GeoJSON-LD in order to do that. So the next speaker, Karl Grossner, is going to talk about bringing time into GeoJSON, GeoJSON-T, adding time to GeoJSON. He's technical director of the World Historical Gazetteer, and he's based at the University of Pittsburgh. And we've in cultural heritage, we've had a lot of success with sharing data using standards, and this GeoJSON-T standard is certainly something we're using at the British Library, and I'm trying to push at the British Library. So I'm interested on that. Thanks.
Uh-oh. Okay, can you all hear me?
Yeah, I can hear you.
Good.
Yeah.
Thanks. Make a comment first before I share my screen and slides. I wasn't, until this session, I haven't been aware of the map markup language and the as an extension to HTML effort, and I'm not really sure how that new technology would handle vector data. And where I'm coming from is entirely a HTML and JavaScript world of making web maps, which I've been doing for 15 years in the context of historical research and so on. So let me just race through these slides. First, I'll share my screen. And there we go. So I'm assuming that everyone here is familiar with GeoJSON. It's really quite a standard in the universe of, in the admittedly messy universe of JavaScript mapping libraries that render maps to web screens. It's in very common use. It's more or less a de facto standard, in fact, from my perspective, for making web maps, for the data that web maps render. GeoJSON looks something like this. At its core, it's quite simple. You have feature collections, consist of features, and features can have properties, which can be anything at all you say, and they can have geometry. There's some conditions that I encounter routinely in people in the world of cultural heritage and historical research, much more generally, that spans many disciplines and even modern applications. Admittedly, I'm much more focused on historical applications. And that is for some features, time is absolutely an essential aspect of them, that it's not, the answer to where is not some location, but it's a location at time. And this is an example in a little pilot demo thing I built a while back, indicating Poland as a very, very dynamic place. It even disappeared for a while. Other cases that I encounter would include things like this. This is a map of commodity flows between Venice and many ports over a period of several hundred years, rendered in a map, the geometry of it rendered in a map, and the temporal attributes rendered in this case in a histogram. Some other sorts of cases that me and I and people like me encounter routinely would be something like this, a trajectory. That is, this is a particular journey taken sometime during the 4th century. And in this case, and the temporal attributes are of great interest, both overall as for the fact that it occurred within some 100-year span, but also each of those points follows each other in a sequence. All of these cases are not handled at all by GeoJSON in any standard way. People make do. They use the properties element to put in attributes that they want to render dynamically, and then they have JavaScript that interprets those properties and does things in the browser. My proposal, that's now a few years old, is to include a standardized when in GeoJSON. They could appear in a couple of different locations. It could be used to temporally scope a single feature, the way you see it here, which, for example, might apply to a single feature for anything really. A more complex case, in the case of Poland, for example, is you might have a single feature and its geometry is a geometry collection. Each geometry of which has its own when, its own temporal scoping. This is a relatively simple thing to do, and it allows for doing some oddball-ish sorts of things, I think, like journeys and flows and so forth. The question then becomes, well, what should be the structure of when? The idea is that there be some standard structure for a when element wherever it appears in a GeoJSON feature that software that supports GeoJSON-T would know about, would know where to look for it and have some idea what to do with it. At this point, I'm going to point you to some links that appear in the last slide of this and are available to you, and I'll display them also here. A when object can include any number of time spans, so there may be interrupted time spans that are relevant to a particular feature. Could be, it can include named periods. There are time period gazetteers in the world, at least a couple in broad use within the domain I'm in. And sometimes that's all we can say about time. And these other elements, duration follows, is intended to handle sequences and so forth. This is a bonus slide. It doesn't appear in the slide deck that's been uploaded. I'm adding it because the reason for my presentation is that Gethin's group at the British Library and Gethin particularly, has instigated an effort called WebMaps-Chi that is attempting to develop collaboratively software modules, I would say open software modules for maps and timelines taken together. Because for us, as Gethin mentioned in his library context and collections, this is a very common use case. Geographic data is dynamic. And this needs to be rendered in various ways. It could be histograms, it could be stepped points along a timeline, that sort of thing. And there are many other things that creative people will undertake with that. So WebMaps-T is intended to work towards a set of modules that developers of web maps in this realm can just plug in and customize to suit their particular situation. The goal of my talk is simply to raise the question of time. As I said at the beginning, I don't really understand how vector data would be handled with a map element in HTML. And this is very much about data models. So this is all happening before it arrives at the browser, I think. I don't know. So I'm here to learn what is intended by this group, and just to raise the point that time matters an awful lot, and not only in historical cases, but in modern cases as well. There's all sorts of trajectory data, all sorts of modern, relatively modern data about crime, mortality, et cetera, et cetera. All of those features can have very important temporal attributes, and standardizing a representation in the most common format currently in use, GeoJSON, seems to make sense to me. That's all I've got. Thank you.
So thank you very much, Karl. I'm going to jump in just on the point, sort of your question about MapML. MapML's vector model currently is almost directly compatible with GeoJSON. It's just converted into a markup form. Peter can jump in with more specific questions, but it's designed to be as directly compatible as possible.
So I look forward to investigating that. Thanks, Ron.
Yeah.
Me too.
And any link that would direct me to a spec or a draft spec or an outline of that approach would be useful.
Ditto for me.
Okay, great. Well, I'm going to give part 2 of the presentation that I didn't have time for today, tomorrow, as part of my breakout. Following your guys' example, I'm using the time most judiciously to communicate as efficiently as I can. So I'll give that presentation, and then we can do it like a demo or whatever. Once I've done that presentation, the demo's almost not necessary, but always nice to click on stuff. And but thank you very much. Time is a challenge, and we are collecting. Amelia has been leading the charge on collecting use cases for maps on the web. That we're going to reconcile the maps for HTML specifications with that use cases, and in an iterative fashion. So I mean, part of the challenge is to what's in, what's out, and what should be handled by the browser in theory. I know Bryan and Simon are like, we'll keep the requests down to the bare minimum, but and we live in that spirit as well. So, what is the minimum viable product that we can ask that serves, the most number of people? I hate to call it the least common denominator, but that's effectively what it is, right? And that's not a bad thing. I was thinking about math when you're learning math when you're a kid, right? When you bring things to the lowest common denominator, you're able to integrate them then, right? You're able to add them up. So hopefully the analogy works that way. So anyhow, great presentation. I don't want to steal your time, so go on.
You're good. It's most interesting to me because if all I have is the features, how do I reconcile that with I just have the features, I want to give to you a map, and that's literally it. How do I just retain those features and make it so that it works within that markup language? Yeah,
well, there is a feature element that we're proposing that basically is based on GeoJSON. I mean, the thing is that GeoJSON is strictly tied to WGS84. It doesn't have any notion of scale, and there are no other there's no styling of that stuff. It's all up to the browser. So this is like JavaScript and CSS, or CSS and JavaScript kind of debate, right?
Yeah.
So, I mean, what we would like to do for feature is give it a home in HTML somehow, right? So that one geometry context is the map, and the textual content is a 2D browsing context, or like a regular browsing context, I guess. So somehow work that out. But anyhow, I will talk more about that tomorrow.
Well, of course, libraries like Leaflet take a data stream like some GeoJSON data and generate a ton of stuff, elements in the DOM that are entirely proprietary for each one. But so ultimately they live as elements in the DOM, all of these data objects. But
yeah, and the linked data idea, like, so, you know, linked data in the DOM is parsable by, I suppose, linked data crawlers in the sense. So giving features a home in the DOM could be part and parcel of making, you know, the GeoWeb crawlable, so, and more importantly, indexable. So yeah.
Yeah, and like the only difference between the GeoJSON and GeoJSON-LD is that context. So sort of at a really simple level, all I have to be able to do is supply you the context, which you could do with a simple attribute.
Well, one thing I'll mention real quick is that GeoJSON-T is not LD compatible, such as it is, this draft spec that's we're playing with the British Library and elsewhere. Is not LD compatible. It predates really an effort to do that, but it has formed the basis for another format, the link for which is in my last slide, which is linked places format, which is being used in World Historical Gazettes here, which is LD compatible and is valid GeoJSON. It's valid JSON-LD 1.1 and but it's much more elaborate. It's designed specifically as a integration or a contribution format for a couple of gazetteer platforms. So GeoJSON-T very much should become GeoJSON-LDT.
Yes, and just to give you a really easy idea of what that means, the context for everything else already exists. All I'd have to do is add some vocabulary and some constraints around when, to say when is a JSON object, not an array, and I expect it to contain this or that. And by when, I mean kgeographer.org/when, you know, and that's it. It would just be literally connecting up that new element that he's trying to introduce. And of course, some work with the GeoJSON standard people, period, because at some point it would have to be sort of an approved extension kind of thing.
Yeah, I see that as way out. I'm at the stage I've been dealing with this for a long time and proposing adding time to GeoJSON for a very long time, and I just that group has not especially been responsive to the idea, so I'm just throwing something out there and using it in some real applications and demonstrating it and talking about it and inviting others to collaborate in making it an actual spec. And Gethin is very much in that category. He saw it and it suits what he has in mind that would serve the library and museum communities and cultural heritage. And so we're just moving forward and inviting people to help make it a true spec from what it is now.
And so people like me, the chair of the Trip Life community group, I take that as a call, and to know now I should take this to the group when we have our next meeting to say, hey guys, I know we're a year out from thinking about time, but look, there's already a good JSON implementation for it. Is there anything we can use? Should we just use this and ask Karl if we can move it? Like what do we do?
I take Peter's point very seriously that the minimum viable product, or least common denominator. This is in my encounters with the world of standards development. This is always front and center. And it's a frustration for people in my position because I'm encountering just all sorts of use cases and I want to honor all of them. But there is, I think there's a simple least common denominator for saying something about time in GeoJSON. And one of the authors of GeoJSON has said very explicitly, yes, there's such a thing as an event-like feature, but the task, it just seems overwhelming. And coming as I do from the world of geography, academic geography and geoscience, the task of merging or space and time in models and in computation has been an enormous challenge, and by and large, it's just simply ignored, or in terms of standardization. So, yeah, it's not an easy thing at all to do or to think about, but maybe we can make some progress.
I have
Okay.
Oh, sorry. Go ahead.
No, that's what exactly I was going to just say. Does anyone else have questions and want to unmute themselves? So perfect.
I have a couple of thoughts. The first is that the minimum viable product, the viable part is the important bit in there. It's only viable if it allows for extensions, if it allows it to be grown into its natural set of use cases and requirements, even if not everything is supported at first. There needs to be a really good use case and requirements discovery phase in which things are not excluded from being future enhancements of the thing. So that's one thing. The MVP needs to be viable. It can't just be a bolted on solution.
Yeah, you need to have a story. You need to have a coherent story for extension, right? So
right.
In my world, I think of that as progressive enhancement. So
Sure.
what is the core behavior that you want to have, and how can you move forward from there? How can you put those time sliders that animate the map and so on, and that's what I think. That's how I think of it anyway, is through progressive enhancement.
You actually we didn't rehearse this, folks. It's a natural segue into my next point, which is animation. There are two ways that time is dealt with in the web right now. Well, two main ways I'm thinking, like in the HTML context. The first is timed media, things like video. And the second is animation, as in CSS animation, SVG animation, or JavaScript animation in general. And, Karl, if you were to take the data from that Poland, right, and timestamp the different states, right? I mean, by states, I mean the different geometric bounds. You could use CSS, for example, to tween, or SVG to tween between different states, different expansions. And I think that animation in that sense really needs to be considered. What are the native animation capabilities of the web, and how is that going to feed into the geometric expression? So I'd love to see, for example, like Poland go from small to larger and larger, and shrink again to nothing, and then bounce back into existence over time. Lots of other animations of like movements of language groups through Europe, use of changes in borders in general, political movements, animations of trade routes, etc. Animations of slave routes. I saw a really compelling one recently of where the slaves started and where they ended up in where they started in Africa and where they ended up in the Americas, and it was in the pace at which it increased until it started slowing down and died off. That was an emotionally, culturally relevant piece of thing, and you can't do that if you don't consider time as a natural part of geometry. I mean, for that matter, the world spins, right? Like when is something open as well? Like when is a business open? Okay, I know where the business is. When is the business, right? When did it close down? This also ties into the time aspect that Brandon talked about earlier. He has, well, he didn't mention it much, but he has this project of, 80s.nyc, which looks at historical things about the New York City. Again, temporal, right? When did any given event occur in a timeline at a particular location? I don't see how we can really think that we're representing geospatial information if it's not also temporal. So Karl, thank you for
that's the money line. Thank you.
No, you're welcome.
All of those historical.
You can PayPal me the agreed upon amount later.
All of the historical cases you mentioned are quite routine cases that are being done right now routinely in academic research applications and so forth, but they're being done with unique ways of expressing time within properties in GeoJSON and JavaScript. That's the way they're being done. So because we're interested in a linked data world and being able to share things, and we have this sort of standard way of dealing with space, there's a real impetus to include time in that standardization to facilitate integration via linked data. So I know that there are myriad modern examples. You mentioned some, like stores opening and so forth. That's not my universe, so I'd be bringing these historical cases to the table. But I know, and I've seen other discussions about time and time modeling and so forth, W3C time modeling and all of that, that there are very many modern cases, and there is a W3C time group that has produced documents and standards and so forth. Yeah, but delivering that to the web is a kind of a separate but very connected issue.
Yeah, I wanted to reiterate something I just glossed over, which is that we should be looking at how mainstream things like CSS deal with time as well, right? And make sure that there's a concordance between how we represent it in GeoJSON and how it could actually possibly be animated. Just a thought. Where animation is relevant, right? It's not always going to be relevant, but sometimes it will be.
I think that also the edge case issue is one that both presentations deal with well, in that when you get a group of curators or academics together, you there was this particular building and it moved here and then it moved there and then it moved here, and where do we actually put the building, when it changed name and then changed back to its original name, for example. And so Bryan's presentation, web annotations, allows us to actually make assertions that can take advantage of those, that can communicate the complexity of those edge cases. And I know that Karl, in working through quite a few different iterations of temporal spatial modeling, has also really considered those very well. And so I think that's something in understanding those edge cases, that's something this community can bring to a broader audience or a broader set of use cases.
More stories, please.
So does anyone, are there any other I don't know what the time limit actually is on this.
Right.
We'll cap it at the end of the hour, but I guess one question is sort of what comes next? What are you hoping? I mean, I think it sounds like you're going to have lots of collaborations between the GeoJSON-LD and the GeoJSON-T projects. What else from the web community or the rest of the geospatial community?
So I know with IIIF Maps, that community group, for example, as I showed you, the GeoJSON-LD context as it is right now is a no-go. So we are trying to just support the migration of that specification so that I can add that at version tag and perhaps maybe supply some more bounds to properties. Having something so open is actually sort of against some of the things linked data wants with permanence. We don't really want it to be anything. We want it to be flexible on these terms. And so we need to do a little bit of work around that. So I'm working with community groups, and I chatted in the Gitter sort of the links to the stories that we've collected in IIIF, and I'm bringing in those use cases and bringing them to thinking on, you know, how are we doing this with resources? I mean, what I showed you was a simple geolocation example, but imagine a map is an image of a map when there are no coordinates involved. A map is just an image. What gives map its mapping is, and correct me if I'm getting my vocabulary wrong, georectification. So I showed you simple geolocations that assumed a georectification, but what if my entity was just that image and I want to apply the georectification to it in my own data set as an annotation? You know, is that even possible? So how this spreads, you know, there's so many things you can do with geo and so many things that are just image specific that aren't map specific. So I think a lot of the work we're trying to do for the future is what are those map specific things that go beyond this being an image that we need to account for. And of course, this takes stories and use cases and trial and error and people like Karl come in and going, you guys didn't even consider the time dimension. What are you thinking? Like it's all of that.
Well, actually, the annotation working group did consider the time dimension. Annotations can be time-stamped.
Yes, they can. And especially with IIIF AV, we have worked in those temporal assertions for things like video and audio files, but not for images, which again is important for an image of a map. You have to realize at its base, that's a lot of times just what a person thinks a map is. And if you just give me the image with no georectification, I can only treat it like an image.
Well, I guess well, to pitch my product a bit more, like I'm not already doing that enough, but the a map element would be georectified. So if you wanted to georectify an image, you would have a georectified target into which to do that process. So I can imagine that would be a hefty WASM or JavaScript process. But I mean, I've seen like, yeah, I think the New York Library had a site that you could georectify images to a historical base map.
Yes.
So
yeah, lots of those little demos out there. We've looked at them.
yeah. So anyhow.
Okay, well, I mean, if people don't have further questions,
What about layers? You know, I think layers are an important fundamental thing of maps. Sorry to stretch things out for people, but I just wanted to get some of the, you know, the primitive, I want to, you know, basically see what you guys think about, you know, what is a primitive feature of maps. And in my world, layers are everywhere.
Absolutely.
I mean, Yvonne Sanchez was saying everything's a layer in his blog post. Everything's a layer. Forget the idea of layers. But, you know,
yes.
That sort of makes it a good target to actually implement.
Yeah, I mean, in our use cases, things like that go completely outside of maps, but like a layer that is transcription and a layer that is translation. How do we supply that for our objects? We don't have a specific layer. We use the combination of annotation collections and annotation pages. And a structure called a range to sort of organize whole or pieces of like entities, and then supply the different layers, if you would, collections or pages of information. And that's sort of how IIIF deals with that primitive in their case. I don't have a direct answer for you. I just have the one, that's around my community.
Can you provide a link about on that topic?
Sure, let me go grab it.
Well, not now, but whenever. I would be interested in.
Yeah, I can absolutely grab you a link on that topic. We do talk about it.
I will say I've been keeping notes in the chat, so kind of drowning the chat in the notes, but I'll copy them all over into a discourse and we can add all sorts of links and whatever there. And of course, we are still recording, so this will go up with the YouTube video of the main talks.
Thanks, Amelia, for doing that.
So this definitely doesn't have to be the end of the conversation.
Yeah, thanks. The notes have been fantastic, actually, because it's been dropping in and out for me a bit, and really appreciate that.
Right, me too.
Yeah, I think you mentioned, Amelia, next steps, and it occurs to me, we're talking about extending GeoJSON, so a natural thing to think about is how to put these ideas about extensions before the GeoJSON maintainers or community of developers and so forth. And there's no immediate uptake. As has been mentioned in the talk about MVP, GeoJSON has a term that's specified called a foreign member. Foreign members are allowed. They'll just simply be ignored by all software that doesn't specifically look for them. And that's what when in GeoJSON amounts to a foreign member. And at some level, the GeoJSON maintainers could care less what foreign members anybody adds and what they might want to do with them. So the idea, my initial inclination was, well, time ought to be part of core, following what some have been saying. It's really elemental, I think, that a very long list of use cases can be put forward, but it's not clear how that's going to proceed. The JSON-LD, GeoJSON-LD does not really non-existent. It's not really truly spec'd at all. It has an alias file that just points to some stuff that I don't think makes it really useful RDF. So I don't know. That's my open question for what next. And in the meantime, I'm just going to keep proceeding, working with Gethin and others who may, to create a format that the sort of software modules he's imagining, map plus timeline, can work with, and then put it out there and say, isn't this cool? Is this cool enough to standardize? Are there enough use cases to support even thinking of it as a standard? So
yeah, and if he's working with communities like us, even in that prototype stage, we could probably produce an LD context for it just to bring you into that game. And then you're there, and it's in a place where we could start to test it and tell people to use it and give us feedback.
It's definitely getting some traction. So in the work that Gethin is doing and in the IIIF community, the idea of adding time has caught people's attention, and there's attention to it. So that's great. And in the meantime, I'm writing software.
Writing software is the best thing you can do. That way we can pave the cow paths, right? Find actually what the hard parts are, fix the hard parts in code.
There
so
you
it's
go.
not theoretic, and then standards can follow after.
That's been my routine for a number of years now. Now you can see some time in action in some of the links that are on my last slide, including World Historical Gazetteer, which is intended to add time intrinsically to place names, to places, their names, their geometries, their types, and their relations to other places. And so when appears all over the place in the standard for that. It is GeoJSON compatible, but for what that's worth.
What do you do for scale? Does like GeoJSON doesn't have a notion of zoom built into it, so what do you do for that?
Everything is in JavaScript. So I mean, what I work with Leaflet almost exclusively. I've done other things, D3 and open layers way back when, but mostly Leaflet and JavaScript. I make the spaghetti that all people who talk about standards hate, but they love to draw attention to. I make spaghetti, and it works, and it's a lot of the things I've built are pretty robust. They're still running after years, and so. But there's a better way forward, and the whole idea of sharing, which linked data and the LD universe proposes, is really my focus, and I think for Gethin and Bryan also, that introduces, it almost compels standard models and ontologies behind those models and that sort of thing.
Right. Very interesting.
I was going to say the very next thing I would like to see happen is a web page goes up that just says geospatial not equal to spatiotemporal, because so many people just assume that because I've done something geospatial for them, they can do that timeline, and I say, without time you cannot have a timeline. Don't you understand? Geospatial is not spatiotemporal. It's so funny because those things are so connected that people just assume.
Right. Well, admittedly, there's just a ton of geospatial data for which time is an assumption, because you're making snapshots at a given time. So you have this temporal frame, and that's what you're looking at. But the stuff that tries to get dynamic, it's different.
Machines don't like abstraction. That needs to be officially said in the data. And like you're saying, it's not a lot of times.
Right. Well, it's hard. It's hard.
Yeah, I bet it's hard. I mean, it's hard for 2 dimensions, and you add the time dimension in there and you disappear.
I haven't even mentioned fuzzy time and uncertainty and so on and so forth.
Yeah.
All of which are of great interest to people who do history, and they're very difficult to formalize.
I've heard saw a lot of talk in the Gitter about the static pages, and just could you imagine representing someone's location over a day using time? You'd have to have a layer or a feature for each second of the day. Like that would be, I mean, wow.
Yeah.
Well, thank you all for your comments. They're very useful input.
Yes, thank you, everybody.
Thank you for joining us. It's been great to have you guys join the conversation.
I want to point out
so much.
sorry, I want to point out one thing. Somebody commented that they didn't know what this work meant in the context of MapML. And Peter, correct me if I'm wrong, but I want to emphasize that this is not a MapML workshop. This is maps on the web. So it's all this stuff is welcome. All this stuff informs, and it doesn't even have to be W3C or OGC, right? This is about what are all the moving parts and what do we need to do to connect them and to get them all meshing. And there are lots of moving parts. So I want to make sure that people feel like their contributions are welcome in this workshop, because otherwise we're just going to have a partial solution that doesn't solve everything.
Yeah, well said, Doug. I think the point of this workshop, which we should have had years ago, but which was only suggested to me by Mike Smith last year, so I blame Mike, was that is to just to highlight exactly how valuable and important maps and location are to humanity, and to try and put that into the context of the information system that is the web, and to, you know, raise the profile of how we're dealing with maps. In my opinion, we don't recognize that everything, like you said, everything has a location every second of every day. And that is just as important as, in some ways, as human thought, right? Having the web to allow the expression of that information in an easy way, like a way that the web, you know, has paved over for us, is valuable. I think it's like inestimably valuable, actually. So that's why the workshop is here. It's not about, I mean, we've been working on MapML as a community group for a few years now. Since 2014, we started the community group when the spatial data on the web community or interest group was created at a workshop by, you know, I had my own say, and we started the community group. And you know, over time, I've just become, you know, more convinced that spatial information is, it's a primitive in society. And well, we're having a workshop. We'll see where it goes.
Can I add something?
Yeah.
Because like for me, like I'm also really glad that this workshop is happening, because I'm working with maps like 10 years, and most of the times like I needed to use like QGIS or other things like that. And when I started to going to web maps, like leaflet is kind of the default. But yeah, I envision the future when we will not need to have like leaflet and other things like that. And also to be like really simple, like when you learn HTML5, to be able to to be able to implement a map really simply, and have simple things that maybe we will be able to implement direct in the standard. Like maybe also because I'm working with like bigger data set, like I need to show 50,000 points on a map, and usually even the DOM doesn't handle this. So it will need to be see how we could do that at scale. And like clustering, like when you have 50,000 points, you definitely need clustering. And like currently we are using like leaflet and the clustering or Mapbox, but I think it would be much more better to be able to kind of get rid of all of these libraries that some will become unsupported. Like we've seen leaflet, but most of the people of leaflet, they are now working at Mapbox, so they will probably not continue to evolve leaflet in the same way. So I think it's really good to have something more of a standard than different libraries.
Yeah, that's a really good way to put it.
Yeah, absolutely. That's great. And I just come back to progressive enhancement. You know, the objective of maps in HTML is not to get rid of libraries, but it's to make them faster, better, easier, and to, like, you know, the whole human world of thought and ingenuity could be applied to maps. And, you know, we could take the lowest common denominator and build that into the engine that everybody uses, the browser. That would be a big step forward, in my opinion. And you know, I don't think there's any magic solution to 50,000 points in the browser, right? Like that's a lot of data, and you have to have strategies. But anyhow.
Just sit there and let it lazy load for a week.
Yeah.
Well,
all right,
I think
we're kind of out of time, right?
Yeah.
I'll let you shut us down, Doug or Amelia. Take it. Thank you very much, everyone, for participating anyway.
Yes.
Very inspiring. really enjoyed participating in this conversation. Thanks for organizing it. And thanks, Gethin, and thanks, Bryan and Karl, for really seeding the conversation with some excellent material. And with that, I think we will convene for the day. Amelia, do you have any final housekeeping?
No, I think everybody's left knows the deal for now. So I hope to see most of you again tomorrow. And I'd like to thank you all for this session, since we didn't really know how it was going to work out, but this was a really great conversation.
Yeah, thanks very much, everyone. Really appreciate it. And I've really enjoyed the whole week so far, you know, and it's been great. I've really learned a lot, I should say.
Yeah, very refreshing to see how much work is going into this.
Awesome. Thanks. Okay, bye for now then.
All right.
Bye, all.
Bye, everybody.
Thanks, everyone.
Thanks. Bye.